Hello, I'm Bruno, cloud consultant at Google, and today we will talk about site reliability engineering. So SRE is something Google invented a few years ago, and it has been a competitive advantage for us. We keep it secret for years, but since now we are a public cloud provider, we share it with customers. So nothing is mandatory. You don't need at all to do site reliability engineering to be in Google Cloud, but if you are interested in, and we have many customers asking questions about, that could be a good time to start a discussion about SRE. So in SRE, what is the most important thing? The most important thing is that we started SRE to solve some issues. The main issue we had was the first one. In the digital economy, when you start a service, if the service is not reliable enough, then you just lose the customer. They don't stay on your website. They don't use your e-commerce site or Maps or YouTube or any services we have. They just move to the competition. So reliability is definitely not an option. You need to be reliable enough because there is no barrier. The competition is very open and people in a fraction of seconds could move from one application to another one. So the first important thing with site reliability engineering is that it's cultural. Everybody at Google think about reliability, not only the developers or the people in operations, but also the product owners and all the management stack. For each product we have, and we have a couple of them with more than 1 billion users, the main feature is reliability. It's a common feature to any product. It's really important, and the product owners put it ranking number 1. Why? Because if you don't have reliability, you can't see anything else. When that feature does not exist, everything else you have invented, all the innovation you did is masked. You can't see it because it's not reliable enough. So that's the starting point. Then the second characteristic of the digital economy is innovation. It means that in the tech industry, on the internet, on the digital economy, tradition is not recognized at all. The only things people recognize is about innovation. So if one competitor is moving faster, proposing nice features, innovating services, then the customer moves quite immediately. So you have to be both reliable and providing innovation at the same time. And that's not an easy story. Because usually when we did IT for 30 years, we know that when you do innovation, you do changes. And IT don't like changes because that's the main reason why the system falls down. So site reliability is about that, solving that complex equation between being reliable and being innovative at the same time. So it's about finding a balance, the right balance between those two things. Then let's have a look about how most of our customers' IT are organized. What is the current setup? So for years, the main objective of IT has been to support the business. And as any support services, the most important thing is to be driven by cost. If each year you could say, my budget is reduced by 5%, everybody are happy because you are lowering the cost of the company. And if you are just supporting services, that's fine. The best way people find to reduce the cost is a kind of setup I put on the slides where there is big silos. A very big silo for application on the left, in the middle, a very big silo to run the applications, and then another big silo to do the maintenance work. Everything is based on a common infrastructure, probably a private cloud, sometime in public cloud, but each box needs to be massive, to be big. It's really a scale economy because then you could go to an Outtasker and ask to that company to do all the stuff for you. And the bigger the deal is, the lower the price is. So this system works very well for 10 or 15 years. It's very efficient in reducing costs, but of course it is very siloed. So if there are strong silos, it means that it's difficult to cross from the left to the right. And in the digital economy, we said just before that we need innovation. We need a pace of change quite important. And that setup is definitely not recognized to be agile. It can't support the digital transformation. So basically, it means that when you go for site reliability engineering, SRE, the best thing is to go for an hybrid setup, saying you have existing things that are done like on the slides. They are really fine, and they're mainly targeted toward cost efficiency, but that is not the right setup for the digital economy. In the digital economy, we need definitely to solve that equation that's impossible to release very, very fast and still keep the services stable. And that's all what SRE is about. So to rephrase it a little bit differently, if we want to be successful with SRE, the first thing is not to do it when you don't need it. So if you have this problem, being fast and stable at the same time, then SRE is the perfect problem solver for that. If you have some other applications where you don't need to change the application very often, so then no high cadence of release, you don't need SRE. Or if you have other means to be stable because you could do slow change management in an ETL-like fashion, that's also perfectly fine, you don't need. But every time you have this complex equation to solve, doing a lot of change and keeping the thing stable and finding the best balance between those two things, exactly, site reliability engineering is the solution for that issue. So, on what it is based, we reuse a lot of Agile and DevOps. Usually people say site reliability engineering is just Google flavor of DevOps. And that's true, because it's completely compatible with DevOps. We definitely reuse a lot of the principles. It's also completely compatible with Agile development. We love when people do small release. It's much more efficient to preserve stability than having a big release that is breaking everything. But Agile and DevOps are two different things, and they are not well aligned from end to end. So SRE will try to build on what I put on the slides, but also definitely to find a common end-to-end perspective to Agile plus DevOps and not two separate things. So, site reliability engineering means what? We have the word site because initially we had only one service. It was Google Search, so the website google.com. Today you could replace site by any services. For us, it means map, it means Google Drive, it means Google Cloud Platform, the search, AdWords, and many, many large services important for us and for our customers. You could replace it by the services that are important for you. It could be online banking, it could be retailing, it could be any industry, IoT things that is mattering for you, no worries. The second word is reliability, because everything is based on that. And the third word is probably the most interesting, engineering. Usually when you want to run application, you call an outtasking company, and they just give you operators. Operators are not usually engineers. That's where we do the things differently. That's where there is probably a disruption. The starting point is to say, hey, we are a software engineering company. We need to solve the problem of doing operation on the internet. What if we take all our engineering skills, because we are software engineering people, and apply them to operation? And that was the starting point of site reliability engineering. It's not easy to start because you need, from a hiring perspective, to hire people that are software developers, software engineers, and ask them to do operation. That is not easy. It's already not so easy to hire software developers with high skills. And if you say them that won't be to do software development, but that will be to do operations, it's even harder. But once you do it, once you find those people that are not easy to hire, but very skilled both on dev and ops with software engineering skills, then you have a lot of benefit. The first of them is that they could talk with developers very easily. They are skilled on the same way, and they are talking on the same level. It's not developer here and operation there. They are really talking equally. When there is an issue on operation, they could drill down in the code directly because they are or they were developers. So they perfectly know how to read code, how to find the root cause, how to find the specific place where to fix the code to make it not break anymore. So that's the first benefit that is critical. The second one is about automation. When an SRE team needs to do something, it could do manually, but they don't like that because they are developers and they don't like the toil, the things that are not so much interesting to do. They try every time to automate it, and they do that very fluently because they know code and they could write the solution. So it means that they are developing their own monitoring tools when they need, or continuous integration, continuous delivery tools, the release pipeline. All those things are fully automated. Another benefit of having operators that are basically developers is that they also have data in their mindset. And that was quite natural for us because all Google is running on data and data analysis and big data. So that brings to operation a very data-driven perspective. It means that when they need to take a decision, and usually in operation, the critical decision is, do I push that release or do I stop that release? Because it may hurt my system. To take this kind of decision, most of the time, with most of the customers, it's based on experience or based on, I am the manager, I know how to do that. That's definitely not the way we do it. We try to find good indicators based on data to take such important decisions. And that's also a benefit of having hired people that are developers and operators in the same time with a data-driven perspective. So that said, how it fly? At the heart of site reliability engineering, there is one key principle. The most important one is named error budget. It means what? It means like in DevOps, we definitely think error is something important. Because if you don't have mistake, if you don't have errors, it means that you are never trying for the impossible. You are never innovating. So innovation just do not exist without errors. But of course, you must not have too much because then you will lose the customer. So error budget is a way to say errors are important, and yes, we have some. And because they are important, we give them a budget. If you are in the budget, it means that you keep the people happy. There are some errors, but not too much to lose the customers. If you overconsume your error budget, then you are in the red zone, and it's time to take consequences to slow down innovation and preserve reliability. But having that budget, managing it, is definitely the way SRE balance between innovation and reliability. So, how do we do that? We need a measurement. So to measure reliability, we have a couple of key indicators. Usually availability is the first you have in mind. In the past, we measure availability with the proportion of good time when the server is up versus the time where it was down. So that was a traditional perspective. It's not a good formula because, for example, if you have a Black Friday and you are a retailer, not every piece of time has the same weight. The Black Friday is a period where it matters a lot. Maybe some other periods you don't have customers. If the site is down, it's not important. So we flip that to a more modern measurement that you see on the bottom right of the slide that is measuring directly customer interactions. So number of requests. Is the request good or fail? Is the request fast or slow? Is the data up to date or obsolete? That's definitely what we want to measure. Anyway, all those indicators land very simple on only one formula that you see on the screen. It's the count of good interaction divided by good plus bad. That's very, very simple. And then you play with it. So it gives you an availability rate. What is the error budget? That's very, very simple math. It's 100% minus the availability rate. It gives you, for example, if you decide to be at 99.9 availability, a 0.1% of errors. And then you deal with it. You could measure it on usually 1 month or 4 weeks in a sliding window. And you could do that every minute. You could measure every minute, what did I do for the last 4 weeks? If you are in the budget, meaning you have consumed a maximum of 0.1, for example, %, then perfect, it's fine. You could still take risk. You could push releases. You could add new features. You could make anything the product owners want to do on the product, and operators even don't look at them. you release using your CI/CD pipeline, and they are fully autonomous to push the release. On the second perspective, what if you overconsume your budget? Like if your credit card, you spend too much and the bank is saying that's too much for what you own. That could be the same for an error budget. What if you consume too many errors? Then we will take consequences. And that's a big differentiator of SRE at Google versus SRE with others company. When we overconsume the error budget, yes, we take measure. There are consequences. We say that we have site service level indicators with teeth. They are really taking measures. So the first one and the most important is to slow down release. Because we know that if we slow down release, then we will have less change. If we have less changes, then, of course, we will have more stability. So you see, it's a system that is auto-balancing by itself. If we think that our customers are getting less and less happy and we are below the objective, then we slow down the innovation pace. During that time, customers again build the trust and are happy. And when it's okay, we start re-releasing a lot again. Third scenario, what if we are at 100% of availability? That looks weird. So probably we will question the indicator. Is that a real indicator? Are we really measuring the customer pain or not? If it is a real indicator, probably we will go back to the development team and say, hey guys, what are you doing? Are you innovating enough? Because on the digital transformation market, if you are not innovating, you just lose. So that's a kind of paradox where operators will go back to developers for asking for more changes. But that's a real life and it's based on data. So you see, there are multiple benefits of doing so. The first one is that we have aligned everybody on a common incentive, on a common metric. Developers, operators, product owner. The three teams that usually fight each other against release, against not accepting them for developers, wanting to put them for devs, now have an indicator that balances the rhythm of release and make it much more smooth. So for me, the most important part about site reliability engineering is that it is collaborative. Instead of having people fighting with opposite objective, it puts everybody on the same page looking to the same objective, and that works. So that's really something interesting. Also, I like in SRE that it is self-balancing. It means that if I am a developer and I know I have a crappy release, I won't fire it. I won't push it in the system because then it will come back into my plate anyway. It will go back and say, okay, the release was not so good. We lose the budget. Now you can't release anymore. So it's really self-policing. That's really interesting. If I am a product owner, I give the objective. I say if it is 2 9, 3 9s, 4 9s, or 5 9s, because I know the market. So first benefits, I won't never go negotiating and asking for 100. Because if I am asking for 100, I'm just killing myself. I'm saying, it's important I want 100. I want no innovation. That's not the case. On the digital economy, without innovation, I can't survive. So I avoid those kind of ask, 100% of availability that are meaningless. That's really, really good. And for the top management, that's great too. Because in the current system, there is a fight between PO, devs, and ops. And that fight go to the decision makers. And they are not targeted to do these kind of decisions. So it will be much more better if people could self-manage themselves and found the common indicators and make the decision themselves than always escalating to the management to find it. So it saves a lot of decision fatigue. So the service level indicator is the first thing we do. A good indicator telling us if customers are happy or not. Service level objective is the value we bench against. Our SLI is below or upper the SLO. Basically, we only need those two things, SLI, SLO. With that, we are done. But everybody is speaking about SLA, service level agreement. So what it is? Do I need it? With site reliability engineering, you don't need it. Definitely not. An SLA is something that is legal. It means if you don't perform at the SLA, if you are below the service level agreement, you need to send back money to the customer. So it's no more thinking about having happy or sad customer. It's already the fight. So SLA is something we have at Google, like everybody have, but it's not done by the people running the system. It's done by the marketing people who need it to sell the services and by the legal people who need it to be sure that we don't overcommit. So everything about SRE rely on service level indicators, service level objectives, and we leave SLA to the people who need it, marketing and legal. So if we sum up, you see that everything is based on existing best practices from agile development or from DevOps, but with site reliability engineering, it's end-to-end, and you have a common objective for everybody. What are the impacts when you adopt that? There are quite a few. You impact your monitoring system because you need to monitor everything with relevant metrics. The roles change. Developers need where to measure, what is relevant in that application. It's no more only the operators. So that's a huge impact. Second one is about capacity planning. That's also something site reliability engineers take care. How could I be the most efficient to run that workload with just the resource I need? Third one is about release management, of course, because we are dealing with the pace of innovation. So we impact also the release management process. And the last one, the last green bullet, is about emergency response. This one needs a little bit more focus. Incidents are key, especially the major outage, because it's definitely something where you not just want to restart the service. You want to learn why this services was down, so you could definitely fix it and avoid to be down a second time. So an outage is definitely a perspective to improve your services. And if your competitors are improving on outage and you don't, then they will win. So that said, what is the best way to do a post-mortem when you have a big outage? So the best way is not to ask the question why. Because if you ask the question why it was down, then the answer will be because this guy, she or he, does that. And everybody will stop talking. So at Google, we do it a little bit differently. We avoid the why question, and we always say how it has been broken, how it is possible to break that system. And once we know, we put any countermeasure that is necessary to avoid it a second time, and we reward even the guy who break it, because we learn something and we improve it. So that's really important to be in a blameless postmortem philosophy. Okay, then if we sum up, how SRE rely to DevOps. So in DevOps, we care a lot about to reduce silos. That's definitely what we do with error budget. Everybody on the same page. In DevOps, we accept failure as normal. Yes, we do too in SRE because even we have a budget for that. In DevOps, we try to have gradual changes. Yes, also in SRE, that's the best way not to burn the budget in one row. If you want to burn it very progressively, release must be progressive, so perfectly aligned. DevOps like automation, we do too, and that's why we hire the people, like I said. And in DevOps, you measure everything, exactly. We are data-driven, and I explain you how it was specific about SLIs and SLOs. So, how could you get started if you are interested? Very simple. The first thing is that you need a workload. Don't try to do SRE like that. Try to be specific on that workload. Is at the heart of my digital transformation. Yes, I have that problem of innovation versus reliability. SRE could help me to solve that. Identify one. Then you start defining your SLI, SLO error budget and driving your operations like I propose with the balance between one and the other one. It will require step 3 to adjust probably your monitoring system so you have the right tooling, and then also to review your outage process, major incident process, to be blameless. And that's enough to start. There are plenty of other topics to do with SRE, about the way you do disaster recovery, about the way you do capacity management, plenty of others. But if you want to start with the most efficient and most accessible, those 4 steps are definitely which one I go for. So, if you are interested in more information about site reliability engineering, there are a couple of books. I put 4 on the slides where you could find plenty of details and even feedbacks from the team who are really driving their operation using site reliability engineering. That said, I would like really to thank you for your time watching that video and being with us. I hope you enjoy it and you would like to discover site reliability engineering a bit more. We are happy to help you to put it in place on Google Cloud Platform. Thank you so much.